Hello and welcome to The Road to Net Zero, a podcast from the Advanced Propulsion Centre. My name is Clem Silverman, and today we're speaking about the motors for electric vehicles, how they're made, and issues surrounding the supply chain of materials involved and what alternatives are out there. Now, some may think that, unlike their internal combustion equivalents, electric or e-motors are pretty homogeneous and lack va-va-voom, literally. But there are still options open to OEMs exploring different ways of applying electrical traction. The APC's Technology Trends team have released a new value chain report to help unpick motor production steps and their inputs, and have provided a cost analysis which you can download now. I sat down with one of the authors, Chris Jones, to explain more about electric motors and touch on things like rare earth magnets, e-steel, and recycling. Here we go.
Hello, we're here to talk about e-motors. We're here with Chris. Chris, explain who you are and what you do.
I'm Chris Jones. I'm Strategic Trends Manager at the APC. I work in our Technology Trends team, and we look at forecasting what's happening with technologies and markets relating to electric vehicles globally. I've been focusing recently on electric motors and I've developed this new value chain piece.
So tell me a bit about this value chain report on e-motors and how it fits into the work you do at the APC.
So at the APC, we regularly produce value chains for different technologies and look at cost analysis across those value chains and where UK opportunities are. We produced a value chain for electric motors a few years ago. It focused solely on permanent magnet motors. The world has moved on a bit there, and there's a proliferation of different designs of motors. So we decided to look at that, to look at the material supply chains as well, inputting into those motors, and did a cost analysis across the full production value chain, looked at where the UK can play.
Chris, tell me about e-motors or electric motors, what they are and what they do on a vehicle.
Yeah, so assuming you own a car, even if it's an internal combustion engine car, you could have a couple of hundred motors on that car, and these can be very small motors. And now we're doing anything from driving your air conditioning to your windscreen wipers to your electric windows. But what we're really focusing on here is the larger traction motors. And what I mean by a traction motor is it takes the energy from the vehicle, and we're talking about electric vehicles now, so the energy is in a battery or it comes from a fuel cell. It takes that energy and it turns it to rotation, which spins your wheels and moves you along the road.
So you mentioned there are predominantly three different types of electric motor, traction motors for vehicles. Which one is the one which is mostly used in EVs now, and why is that changing, and what are we seeing those changes in reaction to?
Yeah, so permanent magnet motors are mostly used now. Something like 80% of the motors on the market will be permanent magnet based. That is starting to reduce. And the main reason for that is to do with the magnet supply chains. So they're predominantly going through China. There are issues with cost stability. And so people are looking at how can we move away either from rare earth magnets to alternative magnets or motors without magnets. There are primarily two types of motors that don't use magnets: an induction motor and an electrically excited synchronous motor, which is known with many different terms as well.
So what are the challenges around permanent magnet motors and the rare earth elements which go into making them up, and what's the supply chain looking like for production here in the UK?
So first off, if we look at why we're using permanent magnets, right, they're great. So if you use a permanent magnet, you've got a nice strong magnetic field. If you use a rare earth magnet like neodymium, you get a very strong magnetic field, and that ultimately means power and efficiency of your motor. So that's why that is the choice of motor at the moment. It's powerful, it's efficient. The problem is the cost of that magnet. The magnet cost drives the motor cost, and that is an unstable cost. The materials that go into that, the rare earths, they're not mined on their own. So if you think of lithium in batteries, that's something that lithium is produced for lithium in batteries. Rare earths are not produced on their own. They come alongside with other materials, and that means their cost is tied to those other materials. Add in the fact that the supply chain primarily goes through China, so 85% of rare earth magnets go through China at some point in their production, and that means that you've got a single source of failure in your supply chain, and that's a risk, and we saw that risk happen with COVID when supply chains were shut down. So that's a worry that can happen again.
Tell me a little bit more about those supply chains for the UK production and manufacture of motors.
So the UK, we don't have these rare earths. Well, we probably do somewhere, but not in amounts that we could financially viably mine them. So ultimately, if we're looking at a magnet supply chain, we'd be wanting to work with partners to develop those materials and get those materials in a sustainable way. One of the issues with rare earths that are produced in China is to do with health and safety. So rare earths are often found with nuclear materials, radioactive materials. And so there are safety concerns with how they're mined in China. And also there are hazardous materials that are produced in the processing of these materials. So we want to work with partners where we can ensure these things are done in a safe and sustainable way and develop those new supply chains. In the UK, we can be processing those materials and producing the magnets themselves so that we have our own magnet supply chain with a diverse material input.
What kind of activity is there currently in that area? So are we already doing that in small quantities or large quantities? What opportunities are there for UK producers to scale that up?
I think if you look specifically at the UK right now, we have Pensana based in the UK who have some activity in this area. There's also Less Common Metals. So there is some small activity. I think in the UK we're looking for a larger demand signal to secure that investment. If you look to the US, okay, we can't really follow the US model because they've created this very sort of protectionist model, which isn't fully in line with World Trade Organization rules. But they've created this protectionist model, and that has created an environment in which new mines can be opened and can be economically run. So they are producing rare earths in the US and producing rare earth magnets, and they're able to do that. They are finding it difficult because of the radioactive elements found alongside rare earths. And that means permitting is an enormous issue, because essentially the military kind of step in and go, hang on a minute, you can't be mining radioactive elements on that permit. So permitting is an issue in setting up supply chains outside of China as well.
And what about closer to home in Europe? What's their response?
Well,
and approach?
The response really at the moment in Europe, that they've got a critical minerals policy which says they want a certain percentage of minerals to be produced or processed in Europe. But in terms of the actual investment, there isn't really a great deal of activity that's looking at magnets at the moment.
As you're talking about mining and extracting new material, at what point will we see recycling as a feedstock become a major source of these materials?
If we had the magnet production, we could pretty much see that now. So the UK has been a net importer of electric vehicles. We purchased something like 2 million vehicles this year, and we'll make around 1 million or so. So we're a net importer effectively of motors within vehicles and therefore the magnets within them. So we have a surplus of materials that we could extract and recycle and put that into a supply chain. And there are companies, very innovative companies in the UK that are working on this to really, at the forefront globally on this sort of recycling technology and ensuring that it's very efficient. So one is Ionic in Northern Ireland, who have been supported by the Advanced Propulsion Centre, and one is Hypermag in Birmingham, who have been supported, I believe, through the Faraday Battery Challenge.
That's permanent magnet motors. What about the other two types of motors? Tell me about those.
So induction motors, there's no magnets there, but the challenge is they won't produce as much power as a permanent magnet motor, effectively from a user point of view. So if you want to try and produce or get to an equal sort of feeling of power, you need to do something clever with the power electronics, and that increases the cost. So theoretically, they could be cheaper than a permanent magnet motor because they don't have the magnets, which are high cost, but you end up adding cost in order to reach that power point. I think we might see that model change a little bit. We're currently in a sort of spec competition where vehicle manufacturers are wanting to have the biggest range vehicle with the most powerful motors and all that sort of thing. I think that will change as we see more cost-conscious purchasing of electric vehicles, and therefore maybe I don't mind if the motors are slightly less powerful and my 0 to 60 is 8 seconds instead of 5 seconds. So that might see a bit of a switch. With electrically excited motors or synchronous motors, they are a bit harder to control. So they need smarter control software effectively. However, that's actually also an opportunity. So one trend that we're seeing is that motor manufacturers or OEMs building vehicles are using the control of the motor to create a different feel. Either they're trying to make it as smooth and quiet as possible, or if you're looking at performance vehicles, sports vehicles, they're using that control to create that sensation of motion, that vibration through the vehicle. That actually, we talk about electric vehicles, people are used to them being quiet and smooth, and say they miss some of the sensation with an ICE engine vehicle. That can actually be replaced through how the motor is controlled.
And are there any challenges or issues which affect across all types of motor?
Yeah, so every single one of those motors requires electrical steel, or e-steel, as we commonly call it. And that is a supply chain that we don't really have in the UK. So we do produce some steel in the UK, but that's dropped, has been well publicised. And we also have an awful lot of scrap steel, obviously, from all the vehicles that we have in other industries. That steel mostly goes abroad for recycling, and it's generally downcycled as well and not turned into new electrical steel. So what's happening is steel that is produced in the UK that could go into that supply chain is going outside of the UK, and those extra steps of smelting it and adding things like silicon to create e-steel are happening in other countries. We then have to buy it back in at a significant markup. And I've heard that it's sort of twice the price within that supply chain. Now, if we were able to create or accumulate the demand to bring that supply chain back, not only would that give us greater security of supply, it would potentially reduce the cost of that supply chain and therefore the cost of motors going into vehicles. But also it's reducing the amount of carbon that's within that supply chain, because currently this steel is travelling around Europe to go into a motor made in the UK, which seems crazy.
So what needs to be done to create that demand currently then?
I think we need to see some clear signals that members of the automotive industry, the OEMs, want to build in the UK. And we have to see that they're perhaps willing to pay a little extra in the short term to do that. You're not going to compete directly with a magnet made in China with a magnet made in the UK. So there has to be something that says we're willing to pay a premium because we know that that's been produced in a safer way, that people have been better looked after, there's less carbon in the supply chain. Some of those things might be driven through European and UK regulation in the future, like the CBAM regulation. The other thing then is looking beyond automotive. So e-steel isn't just used in motors. It's used in creating, in building up the grid. So we're at a period of time now where we need to rapidly scale up our grid, our power grid in the UK and Europe, everywhere. And that's bringing online new energy sources from solar, from wind, etc. So e-steel is needed there as well. So when you look across the markets for the different types of power generation, different types of motors, and the requirements in power lines and power networks, there's a much, much larger pull for steel and e-steel. And that means there's a much greater chance of landing that investment.
What about other cost pressures or other materials, for example, copper?
So yeah, copper is the next kind of key material for electric motors. Now, theoretically, you could use aluminium, but you need a different design. It tends to add some other complexities when you switch to aluminium because it's not as it doesn't conduct as well as copper. That's why you use copper. So that adds challenges if you want to switch to aluminium. Now, there are some really clever things happening in the UK, looking at ways that you could implement aluminium windings instead of copper windings. But in general, copper is the easier material to use, but the cost has been going up, and that is being driven currently by demand pressure. So electric vehicles, the batteries, the wiring harness, it all requires a lot more copper, not just the electric motors. Then you look beyond the automotive industry, and I mentioned power networks. Again, new cables, all copper. Wind turbines, more copper. Solar cells, getting that energy away, it's all copper. So the demand for copper is going up an extraordinary level over the next 30, 40 years. And the investment in the extraction of copper isn't really happening. So it's creating this kind of crunch that is increasing the price.
You've said before that OEM should be looking at paying more, but what about on the consumer side? Should we be looking to pay? Well, currently, consumers are not wanting to pay more for their electric vehicles, and that's part of the issue and slowdown of the increase of sales and things like that we're seeing right now. Obviously, that might shift with various other policy elements or technological changes, but I guess a lot of that will be shifted onto the consumer at a time when they're trying to cut costs as much as possible.
It's a really good challenge, right? So how do we build a sustainable supply chain and manage cost? And that is an incredible challenge. And there are areas where you have to understand that you simply cannot compete with China on cost. So either there needs to be enough scale in those supply chains that you can compete on cost, or there needs to be some other market leveraging by governments in order to help this to happen, alongside innovation that will create more efficient motors, more efficient vehicles that will ultimately bring the cost down. But we are, I think, at a bit of a pain point with some of these things, where there has to be some give somewhere in the supply chain.
Can you tell me a little bit about the value chain you've looked at in this report and what it shows?
So we put this value chain together to understand the production steps and the material inputs. And then a key thing that we've done with that is a full cost analysis across the whole thing. And what that shows is a few different things. So one, it helps us break down where the cost is in the rotor versus the stator. And it very clearly shows with a permanent magnet motor, there's a lot of cost dependency on magnets. So why is that helpful to understand? Well, that tells us if we're focusing on cost, on supply chains, to supply chain stability, we start with the magnets for permanent motors. We then see the next cost sensitivity across all the motors is e-steel. So it makes sense that the next thing we should look at is how do we get a secure supply of e-steel for the UK industry? What is the scale of that industry, not just for automotive, but beyond? And then we see our next sensitivity is copper. So then we look at copper as our next supply chain that we need to fix. So it gives us that prioritization of what should we tackle and how.
Okay, so the report is not the only place people can go for information about e-motors. Tell us about some of the plans that we've got coming up in the near future.
So we've got some events coming up. We have one on the 29th of May where we want to bring the entire supply chain together. One of the things we heard in building this report was that we need to help collaboration across the supply chain, help see the big picture of where the demand is, where there are challenges and where there are opportunities. And by having that discussion across the supply chain, we can come to some common understanding and help move forward.
Thank you, Chris, and thanks to you for listening to this podcast. Have you downloaded and read the Value Chain Report? What are your thoughts on the issues raised here? Let us know via the APC's website, apcuk.co.uk.